Last time we looked if we had a graph in standard form, if we could graph it, which we've done. For a review, go back to lesson 3.08. Right now we're going to work in reverse. What happens if we are given a graph and we need to find the equation, whether in factored form or standard form? So remember that in factored form, we have y equals a x minus r in brackets times x minus s. So I'm just going to rewrite this over here so I have it. Now, from the given graph, I can pull some information. I can see that I have an x-intercept at 1 and an x-intercept at 5. As my key, I'm going to sub in 1 and 5 for my x-intercepts, r and s. So 1 and 5. The equation is negative, so that negative still stays. The next thing I have is I have x's, I have y's, and I don't have an a. So I have 3 unknowns. What I'm going to use is I'm going to use another point. So I'm going to use this point, the vertex 3, negative 4, as my x and my y value, and I'm going to sub them in for x and y. So everywhere I see x, I'm going to put 3, and everywhere I see y, I'm going to put negative 4. I now have an equation with just one unknown, and it's algebra. I can solve. So negative 4 stays over here. I need one answer in each bracket, 3 minus 1. 3 minus 5. Now I'm going to solve to isolate for my variable. Divide by negative 4 on the right. Divide by negative 4 on the left. And I have a is equal to 1, which tells me the graph opens up. It does. Look at that. Now that I have an a value and I have my x-intercepts, I can write my equation x minus 1 times x minus 5. Of course, I don't need to show a 1, so it's just factored form x minus 1, x minus 5. And there's my equation. For the parabola given. If I needed it in standard form, then I would expand and simplify from there. Sub in what I know, solve for the unknown, and then write my actual equation in the form required. Let's try 2 more examples. Alright, it asked me again in factored form. So I remember that factored form y equals a, x minus r, x minus s, where r and s are my x-intercepts. I have one x-intercept of negative 4 and one of 2. So I'm going to sub in negative 4 and 2. So negative, negative 4 and 2. So if I think I need negative, negative 4, that's going to be plus 4 and negative 2. The other thing I'm going to do is look for another point. And there's another point. That point happens to be 0, negative 4. So everywhere I see x, I'm going to put in 0. Everywhere I see y, I'm going to put in negative 4. At that point, the rest of the equation stays the same. A is my unknown. I need to add my brackets, and I'm going to solve. Negative 4 divided by negative 8 is going to give me a positive number. 4 over 8 can reduce to positive 1/2. Now that I have positive 1/2, 1/2, x plus 4 as one bracket, and x minus 2 as next. And I have it in factored form. Ooh, it actually asks for it in standard form. Now that I have it in factored form, I need to expand and simplify. Remember, there's two ways I can do this. I can distribute half into the first bracket and then do binomial distribution, or I can do binomial distribution first. So I'm going to do that first. So I have x times x is x squared, x times negative 2, 4 times x, and 4 times negative 2. That whole thing in brackets then needs to be multiplied by 1/2. If I collect some like terms just to put less work, negative 2x plus 4x. Now I need to continue and actually distribute half into each term of my trinomial. One half x squared. 1/2 times 2 is 2 times 1 divided by 2, or 2 divided by 2, which is just 1. And negative 8 divided by 2. And there is the equation in standard form for my parabola. A value is positive, it opens up, yes. We have a C value of negative 4, which is our y-intercept. There it is. So it still works out. We'll do one more example together. Again, I look, x-intercepts, negative 4, negative 9. Negative negative 4 is positive 4, negative negative 9 is positive 9. I can use any other point. This one, negative 5, 4. This one, negative 3, negative 6. This one, negative 10, negative 6. Any one of these points will do. I'm going to choose that one. Do the math. Got an A value. And I now have the equation of my parabola or my quadratic in standard form. Noticing that negative A value, it opens down, nice. Negative 36 is a y-intercept. Here's the y-axis. If we think about how far it's going, it's probably going to end up being negative 6. And by probably I mean it absolutely is, because I trust the math.